Hello, Twin Tower students. We've talked about how to make sprites move before, but we haven't talked about how to make us move our sprites. So we're going to look at a few ways to do that very quickly. Um, so the most straightforward way and what most students come to first when they're exploring on their own, I've seen this a lot already, is students will take, when up arrow is pressed, move my sprite, uh, change Y by 10. So Y is the height of your sprite, is the up and down. So he starts at Y0, that's the center of the screen, up arrow. So now each time I press the up arrow, his Y, his up down number, how far up he is going to go up by 10. Oh, that's set. I need change Y by 10. So now every time I push it, his Y is going to go up by 10. Now I can do an event, and I can say when down arrow is pressed, now my Y is going to change by -10. So now when I'm pressing down arrow, he goes down. When I'm pressing up arrow, he goes up. But anyone who's done this implementation before might have realized this small problem is that whenever he changes from going up to going down, there's a little bit of a lag on it. And it's not very intuitive to get rid of. So we're going to talk about how to fix that today. And we're going to have characters that can move smoothly across the stage without stopping every time they change directions. I've had a lot of students come up with this on their own already, which is why I'm showing it to you now. And it gives us a good way to talk about these variables. These variables just means numbers that change. So these numbers that change, that mean where the sprite is. So the x variable and the y variable. We don't have to be any more detailed about what variables are right now. But yeah, so as my y goes up, my character goes up. So if I increase y by 10, my character goes up 10. And what this 10 is and this 10 is, these are counting the pixels on this page. So this character is moving up 10 pixels, up 10 pixels, up 10 pixels. As he moves down 10 pixels. As y goes down, he goes down 10 pixels, down 10 pixels. Same thing for x. If I was to create an event for when, right arrow is pressed, if I was to say change x by 10, now when I hit right arrow, his x increases by 10, so he moves to the right. And then I can do the same thing for when left arrow is pressed. And just for my own sake, I could have these blocks lined up like this so it's clear what each other is doing. When left arrow is pressed, I can change x by -10. Now when I press the left arrow, his x is going to go down by 10, which is going to make him move backwards, which is going to make him move to the left. So this is what we want our character to be able to do. We want to be able to control our character. But for today's assignment, I don't want you doing it like this. What I think is what is a lot better. Let me add in a surprise sprite and we'll make this one move. So we'll have a little rat. What is a lot better is if we use when the green flag is clicked, we could start a forever loop. And that forever loop will check if each of our keys is pressed. So if this key is pressed, then I'll do this. If this key is pressed, then I'll do this. So if up arrow is pressed, if down arrow is pressed, if right arrow is pressed, and if, where did it go? If left arrow is pressed. So now I have a loop that's going to forever, so each frame, so remember a frame is one still image, and we get in Scratch about 60 frames per second. So 60 times a second, this is going to check if the up arrow is pressed, then move my rat, let's do change y by 10. If the down arrow is pressed, then change y by -10. And if the right arrow is pressed, change x by 10. And if the left arrow is pressed, change x by -10. So now our rat, green flag, our rat will be moving. It's like our cat is, but our rat is a lot more fluid. So remember, this cat and this rat are on the same controls. They should be doing the same thing. My cat's a little laggy. He doesn't take inputs as fast as I want him to, and in addition, he can't move two directions at the same time. These are technical limitations with Scratch that we can get through by having this forever loop that'll check each direction once every 60th of a second. This cat can only take one of these inputs every frame. Every 60th of a second, the cat can only do one of these things. If I have multiple keys pressed at the same time, it's just going to choose one of them. But with my rat, if I have multiple keys pressed at the same time, so again, this cat, every 60th of a second, every frame, he can only take one of these key button inputs. So he can't, he's really awkward. He's really weird. He takes a while to update. This rat, his movement is very smooth because every 60th of a second, every frame that Scratch kind of runs this project. So once per 60th of a second, it's going to check if the up arrow is pressed, then move up by 10. If the down arrow is pressed, then move down by 10. So if I hold both, I'm holding both right now. This rat is going up by 10 and down by 10, and he's doing it in the same frame. He's doing it at the same time. So he's constantly moving up by 10 then down by 10, but we only see him sitting still. But I'm hitting both up and down on my keyboard. So he is doing both. Same thing for right. I can make him move right and left, and if I do it at the same time, then my cat's going to keep moving because he doesn't realize. The cat can't take multiple inputs at once. But my rat will look, each frame he'll say, if the right arrow is pressed, then change this by 10, so he's moving over 10. And then if the left arrow is pressed, then change by negative 10, so he'll move back over negative 10, and he'll be in the same spot. So obviously those two aren't the most useful, but let's say my cat and my rat are in the same spot, and let's say I hold left and down at the same time. Left and down. So now, oh, the cat actually did it. I can't believe it. I'm very surprised, Mr. Cat. I've never had him do that before. I've never seen him do that before. And there he goes. Now he's not doing it anymore. He just wanted to throw out a surprise for my demonstration. Either way, you guys could try this on your own. The cat's implementation of movement is very finicky. It does not work correctly. I've never seen a move diagonal like that before. I really can't believe that that happened. And honestly, it's slightly changing my understanding of how Scratch handles inputs, that even happened. I must have gotten like a frame perfect, like, oh, it is. Okay, so you have to, okay, so you can make the cat move diagonally if you get a frame perfect input, which we don't have to talk about in this class, but anyone familiar with fighting games or like Super Mario Odyssey or something, platformers might know what I'm talking about, but anyway, let's not worry about that. Basically, what I mean to say is that if I hold, so in this case, I'm going to hold up and right. So my cat is going to move just to the right, but my rat is moving up and to the right because my rat is taking multiple inputs. That's what we wanted to say. Because each frame, each time the game updates, my rat's going to say, if I'm holding the up arrow, move up by 10. If I'm holding the right arrow, move over by 10. So it's going to do both, but the cat is only going to be able to take one input at a time, usually, unless you do some kind of crazy frame perfect input that confuses the game. I get it to work now. So there's something, if you guys want to be really complicated, there's something called a thread, and it can only take one input from the keyboard at a time per sprite. But it seems like there's some limits to that. Anyway, it doesn't matter. Basically, this is what we want to do today. We want our sprites moving like this. Once you get your sprite moving like this, you could add some obstacles for him to avoid, some obstacles, some things that he wants to collect, some, maybe so I have a rat, so maybe I would have some cats flying around just like I do now. Maybe they would be chasing it, maybe they would be bouncing around randomly. I would have to avoid the cats, and maybe I would have to collect some cheese that would randomly show up in random spots on my screen. Maybe each time I collect a cheese, it goes to a different spot, something like that. And I'd have a little rat collecting cheese game while cats run around trying to catch me. That could be a cool little game. You don't have to do that yet. That can get a little complicated because you need a few more things. But we mainly want to focus on these if statements. So if something is happening, then do this. If this condition isn't met, so if this key is not pressed, then this code is just going to get skipped. That's what the if statement does. Is anything in here, and I'm going to redo this lesson after I do the, I'm going to redo this video after I do the lesson probably, because I think I have to maybe practice demonstrating this a few times. But anyway, that's part of why I do the videos, is to practice my demonstrations of these things. But if this condition is true, so if the up arrow key is pressed, then this code is going to run. If this condition is not true, if it's false, if the up arrow key is not pressed, then it's going to skip this code. So if this is true, then this code runs. If this isn't true, then it just skips right past this and goes to the next block. That's if statements. That's what we want to use today. Hopefully everyone has a nice moving sprite for me. And yeah, I will hopefully be able to clarify this a little bit in class, because I feel like this was a little rambly at some points. But it should be fun. Hopefully you guys have great questions for me, and maybe I'll redo the video after I demonstrate this in class. I will see you all next time. Thank you for watching, and email me if you have any questions.